What we're going to do today is look at the difference between linear, quadratic, and exponential equations. So I have just a few basic formulas up here. One is slope-intercept form, y equals mx plus b. It's also in functional form. Functional form means instead of putting a y, we put an f of x. The next one is quadratic equations. We have y equals ax squared plus bx plus c, or in functional form, f of x equals ax squared plus bx plus c. Notice that with linear equations, there's no exponents. With quadratic equations, notice that we have an exponent of 2, and that's kind of telling us that it's a quadratic equation. And then for exponential equations, we have y equals ab to the x plus c, or in functional form, notice that we have an exponent, and the exponent is an x. So we're going to label it as either linear, quadratic, exponential, or neither. The first one, we see it's in functional form. We see that we don't have any exponents, so this would be a linear function. Letter B is kind of a tricky one because we see exponents of 2, but notice that with the quadratic equation, it's x squared. Notice that it's just y. It's not y squared. This technically is a circle. We're not going to get into how to graph circles in algebra, but we will in algebra 2. So we're just going to put neither for right now. We don't have to give the specific definition of what each equation is. It's just linear, quadratic, exponential, or everything else we're just going to say is neither. Letter C, we see the exponent is squared, so we know that it is a quadratic. And then for letter D, notice we're looking at the exponent. We see an exponent of an x, so that tells us that it is exponential. Now, looking at letter E, this isn't in the exact form as y equals mx plus b, but we see that we have an x and a y and there's no exponents. So that tells us that it is linear. Letter F, we're looking at the exponent. We see that the exponent is an x, so that tells us it is exponential. Letter G, we see an x, we see a y. Notice that the x, though, is in the denominator. Technically, that's a rational. We're going to be getting into rationals much later. But once again, we're either saying linear, quadratic, exponential, or neither. So this is going to be a neither, once again, because the x is in the denominator, not the numerator. And letter H, notice that there's an x. There's also a 1, so we might think linear, but because of the x in the exponent, no matter what we add to the x or multiply to the x, because there's an x in the exponent, that makes it exponential. Now, just to kind of summarize, how can we tell? Linear equations, we're looking at the exponent, and what we're noticing is that there are no exponents. Quadratic, the exponent is squared. And then for exponential, the exponent is an x. Or we could say a variable. Now, let's look at some summer topics. So these are all prerequisites for getting into algebra. We should know how to solve a basic one-step equation. With one-step equations, we're always doing the opposite operation. So we see plus sign, we subtract, and we get x is equal to negative 12. Here we see multiplying, so what we do is we divide. In algebra, we could keep fractions as improper because when we move into slope, it's really helpful. And for letter C, we see the division bar, so the opposite of division is multiplication. We're going to multiply it by negative 5. And the negative 5's cancel. We get x equals, negative and negative is a positive, and 45 times 5 times 5 is 25. 5 times 4 is 20, plus 2 is 12, so that would be 125. Now we're going to look at two-step equations. So with two-step equations, we have two steps. The first step is adding or subtracting. It's basically the opposite of order of operations. Order of operations, we always multiply and divide first, but when we're solving equations, we want to add and subtract first. Then, because we're multiplying by 2, we're going to divide it by 2, and we get negative 2. For the next one, we're subtracting 8, so we do the opposite. We add the 8. Because we're dividing, the opposite of dividing is multiplying, so we're going to multiply it by 4. And then for letter F, we're adding 6, so our first step is to subtract the 6. And a fraction, this right here is the same thing as y over 2, so we could think of it as dividing. So what we're going to do is we're going to multiply by 2. When we multiply by 2, the 2's cancel. We isolate the variable. Isolate is just a fancy way of saying get the variable by itself. What you should do is pause it for a second, try to solve them on your own, and then start it back up and see how you did, just to see if you're understanding it. Okay, so for letter G, we're going to first add the 2. We get 3x is equal to 9. We divide it by 3, and x is equal to 3. For this one, we're going to subtract the 4, and we get y over negative 2 is equal to negative 1. Remember from last time, a positive and negative different signs we subtract, so that's why it's negative 1. We multiply it by negative 2 in order to isolate the variable. Whatever we do on one side, we do the same thing on the other. And then for our last one, we subtract the 8. Because this is a positive 8, remember we're always doing the opposites. And that gives us negative 6. Remember, this right here is the same thing as x over 3. So we're dividing by 3, so we're going to multiply by 3. That's the opposite. 3's cancel. X is equal to negative 18.